Clay class. This is Tuesday, August the 10th, and several students have been out lately, so I thought I would record some of these classworks so that you would not get too far behind, or maybe if you're struggling in class, you guys would like to be able to come back and rewatch these videos just as a review to kind of get yourself caught up and go at your own pace. Maybe things are moving just a little bit too fast in class, but today what we learned was a memory device, or a way that will help you set up your problems on either homework, or we have a test coming up on Friday. Maybe this might help you. So what we learned today was a device called molehill, and you've heard many times, don't make a mountain out of a molehill. So we're going to call this molehill, and if I want to draw a hill reminds me of a triangle. And since this is called molehill, we're going to put moles at the top. Okay, moles goes at the top. So down over on the left side of the triangle, and I'm going to draw some grass here. This is going to just help you remember it. Down in the valley, usually there's a lot of grass and things, and I'm going to say we're going to put mass in the grass. And the unit that we measure mass in is grams. Okay, so I can convert between the amount of grams of a substance to moles, or I can convert from moles to grams or mass. So I can convert between these two. But in order to do that, I have to go through molar mass. And we've already had lessons on how to determine molar mass. Molar mass is determined from the atomic mass on the periodic table. So if I'm given mass, and the question is asking me for moles, I have to go through molar mass to get there. And the way I kind of remember that is there's an M on this side of the triangle, and M reminds me of molar mass. So that kind of helps me set my triangle up. Well, on the flip side, the other side of the hill, we can also convert between moles and atoms, or between moles and molecules, individual particles. Well, this A over here reminds me of Avogadro's number, and Avogadro's number is 6.02 times 10 to the 23rd particles. So if I have a specific number of atoms and I want to convert that to moles, then I have to go through 6.02 to get there. Or if I'm given moles and I want atoms, I can convert going back through 6.02 times 10 to the 23rd. Well, just like a real mountain or a real hill, you can't drive through the mountain. You cannot get from mass to atoms, or from atoms to mass, in one step. In order to get from mass to atoms, or atoms to mass, you have to go over molehill to get there, in either direction. So these problems, converting from mass to atoms or atoms to mass, those are two-step problems. So I give you this so that you can write that as number one on your test on Friday and use it to help you set your stoichiometry problems up, or your conversion problems up. So this is how it works. Let's just say the question says, how many moles are in 11.8 grams of water? So you're given this word problem and you want to know, what is the question actually asking me for? Well, the question is asking for moles. Okay, this is where you're going. You're going to moles. Well, what's your starting point? Your starting point is grams. So I'm starting with grams. So I'm starting here in my triangle, and I'm going to moles. So that's a one-step problem. We have to go through molar mass to get there. We don't even need Avogadro's number for this problem. So at this point, we know where we are, we know where we're going, and we know what we need. And it just becomes a simple dimensional analysis problem. So we start with 11.8 grams. And always write the unit that you're given with the amount. And that helps you set up and know what goes on the bottom of your conversion factor. We know it's a one-step problem. We know that grams is going to be on the bottom because it's on the top here and it needs to cancel. So in 1 mole, I have a specific number of grams. Well, where do we find this? This is the molar mass, remember, from your triangle, of water. Water's formula is H2O. We know that hydrogen, there are 2 atoms of that, and each is 1.0. That's a total of 2.0. We know that oxygen has 1 atom in this molecule of water times 16.0, so that's 16.0 grams. Add those together and you end up with 18.0 grams per mole. So 18.0 grams per 1 mole. Now we just work the problem mathematically. We cancel out grams and we're left with moles. That's what the question's asking for. So 11.8 times 1 is 11.8. I'm going to come down here and finish this. So 11.8, my unit is moles, divided by 18.0. We use our calculator to figure that out. Sorry about that bell, guys. So 11.8 divided by 18.0, and we end up with 0.6555, and so on and so forth. But our question has 3 significant figures, so we have to round our answer to 3 significant figures. Here's our cutoff point here. This 5 makes this 5 go up to a 6, so 0.656 moles. And that's how you use mole.